This video looks at double angle identities. Now, if I have sine of A plus B, sine A cos of B plus cos of A sine of B, what if A equaled B? So we'd have sine of A plus A would equal sine of A cos of A plus cos of A sine of A. So sine of 2A is equal to 2 sine of A cos of A. You will find that on your formula sheet. Now if I have cos of A plus B equals cos of B minus sine of A sine of B, and A equals B, I'd have cos of A plus A equals cos of A minus sine of A sine of A. So cos of 2A equals cos squared A minus sine squared A. Again, that is on your formula sheet. Now we can change this one because we know sine squared A plus cos squared A equals 1. So I could write cos 2A equals, replacing my cos squared A, 1 minus sine squared A, which would be 1 minus 2 sine squared A. Alternatively, I could have replaced my sine squared A. So cos squared A minus 1 minus cos squared A. So that becomes 2 cos squared A minus 1. And again, that is on your formula sheet. So make sure you can see where they all are. Make sure you use your formula sheet. So at the top of this slide, I've put those formulas from your formula sheet. So let's simplify sine of 3x minus cos of 3x all squared. Expand our brackets, we end up with sine squared of 3x minus 2 lots of sine 3x cos 3x plus cos squared 3x. Now, sine squared 3x plus cos squared 3x is equal to 1 because of my identity. Also, 2 sine 3x cos 3x is equal to sine of 6x. And that's using our double angle identity. So let's replace. We'll end up with this equaling to 1 minus sine 6x. And that is now simplified. Next, if tan theta equals 4 over 3 and 0 is less than theta, which is less than pi on 2, so this means we are in our first quadrant, so all ratios are positive. Evaluate. We've got sine 2 theta, cos 2 theta, tan 2 theta. So I need to know what sine and cos theta are. The easiest way with this is a 3, 4, 5 triangle. Tan theta is opposite over adjacent. So that's your 4 over 3, and then your 5 is your 3, 4, 5 triangle. So sine theta is going to be 4 over 5, and cos theta is going to be 3 over 5. So sine 2 theta is going to be my 2 sine theta cos theta. Replace 2 times 4 over 5 times 3 over 5, which is 24 over 25. Cos 2 theta is cos squared theta minus sine squared theta. So that becomes 3 over 5 all squared minus 4 over 5 all squared, which is 9 over 25 minus 16 over 25, which is negative 7 over 25. Tan 2 theta is sine 2 theta divided by cos 2 theta. So 24 over 25 divided by negative 7 over 25, which is 24 over 25 times negative 25 over 7. 25s cancel, so that's negative 24 over 7. Let's do some proofs. Prove each of the following identities. For the first one, let's start with our left-hand side. We're going to do replace 2 sine theta cos theta with sine 2 theta. Cos squared theta minus sine squared theta is cos 2 theta. So therefore that is tan 2 theta, which is my right-hand side, and we are done. The next one, let's start with our left-hand side, and let's get a common denominator. So sine b cos beta is going to be sine theta cos beta plus cos theta sine beta. The top is our identity sine of theta plus beta. Our bottom is the identity a half sine of 2 beta. Bring that half up, so we've got 2 sine theta plus beta all over sine 2 beta, which is equal to our right-hand side. Okay, let's look at this one, and we're definitely going to start at the left-hand side because that's more complicated, and we're going to get that common denominator. So cos theta plus sine theta, cos theta minus sine theta. So my numerator is going to be cos theta minus sine theta plus our cos theta plus sine theta. Our sine thetas are going to cancel. So we've got 2 cos theta, expanding our brackets on the bottom, cos squared theta minus sine squared theta. So now we've got some identities happening. 2 cos theta, and the bottom is cos 2 theta. Now I'm looking at that other side. I've got a cosec there, which is 1 over sine. So if I times top and bottom by sine of theta, I end up with 2 cos theta sine of theta all over sine theta cos 2 theta. Now 2 cos theta sine theta is equal to sine of 2 theta. So that's all over cos 2 theta sine theta. Sine 2 theta over cos 2 theta is equal to tan 2 theta. And I'm going to times all over sine theta. 1 over sine theta equals cosec theta. So that is equal to tan 2 theta cosec theta, which equals my right-hand side. Done. Last one. look at the left-hand side. My left-hand side, let's go to cos and sine. So I've got 1 over cos of A minus cos of A. 1 over sine of A minus sine of A. Let's get a common denominator, cos of A, so that will become 1 minus cos squared A. Sine of A would become 1 minus sine squared of A. 1 minus cos squared A is sine squared A over cos A. 1 minus sine squared theta is A is cos squared A over sine A. Do some cancelling. One of those sines can go with that. One of those coses can go with that. So we're left with sine of A, cos of A. There's nothing I can do to get it to the other side. So let's go and play with the right-hand side. So whenever I have tan and cot, I want to go to sine and cos. So sine of A, cos of A is tan. Cot is cos of A over sine of A. Get a common denominator, which is going to be cos of A sine of A. So that's going to be sine squared A plus cos squared A. We know that's equal to 1. So that's going to end up being 1 over cos A sine A, which is just cos A sine A. And now they're equal, so left-hand side equals right-hand side. So I am done.